Question 7. So we're told that the resultant of F1 and F2, so when you add F1 and F2 together, you get, you're acting in the same direction as the vector 1, 3. So basically when we add these two together, it's going to be a multiple of the vector 1, 3. So I've introduced this unknown scalar quantity lambda, okay, because it doesn't equal 1, 3, it's in the same direction as 1, 3, so it's a multiple of 1, 3. The other thing I can pick up from the information is that my force 2 has got the same I and the same j components. Alright, so it might be 2i, 2j or 3i, 3j, but both components are the same because it's in the same direction as the vector ij. So what I've just chosen to do is just, I don't know what the I and j components are, but they are the same. So make sure you're totally comfortable with that, because from then onward this question is plain sailing. We're saying that F1 added to F2 is in the same direction as the vector 1, 3, so it's a multiple of the vector 1, 3, and we also know that the force 2 on its own is in the direction of ij, so for every one along we go one up, so we know the two components, the I and the j components of F2 are the same. So I can now just generate a little simultaneous equation. Looking at the I components, I can say minus 1 plus x equals 1 log of lambda, minus 1 plus x equals lambda, and looking at the j components, I can say 2 plus x equals 3 lambda. So, so two equations, two unknowns, just a simultaneous equation. So I've decided to make to multiply my first equation here by 3, so that I've got 3 lambda here. So minus 3 plus 3x equals 3 lambda. So I've got 3 lambda here and 3 lambda here, so I can equate these two equations because they both equal 3 lambda. So minus 3 plus 3x equals 2 plus x. So solving that, I get x being 2.5. So my vector F2 is 2.5, 2.5 in column vector format. Or if you want to give your answer in ij format, it's 2.5 I plus 2.5 j. Now for part B, I need to find the speed of p when t is 3 seconds, and I'm given the acceleration is 3.9, and I'm given that the starting velocity, so u, is 3 minus 22. So just using v equals u plus at, but just in vector format, I've got vector v equaling u plus a lots of t. Okay, so that's just basically just using this CVAT equation. So the vector v is therefore 12.5. Now I'm being asked to work out the magnitude of that velocity. So the magnitude of that vector, the size of the of velocity is the speed. Okay, so I need to just work out the size of this vector. So that's just using Pythagoras. So what is 12 along and 5 up? What is the resultant vector? So I've just do the square root of 12 squared plus 5 squared, which is 13 meters per second.